thank you so much, folks, for joining. Jimmy gave a great introduction there. My name is Nick Lotz. I will talk about myself here for just a few minutes, not that long. The goal for this workshop is for everyone to, get a sense and feel of 51 Enterprise. And again, the goal here is to really kind of describe things in a little bit of a narrative structure. That is like, why are we showing you all of these features? Why are they useful? What is the actual like enablement of your workflows that we're trying to do here? I love what folks are starting to do in the chat. Saying where you're from is really excellent here. I'll introduce myself here in a bit. So just as a quick note, I think Jimmy went through all these housekeeping items here in a moment. But again, you'll get a link to all resources as we wrap up this workshop a little bit after we wrap up. Feel free to use the Q&A widget in Zoom to ask a question. I do love what folks are doing, though, in the comments right now. This workshop and presentation doesn't have a particular certification attached to it. Jimmy did show a whole bunch of really awesome learning materials in the chat. That's a really good way to dive deep into computer vision theory and practical examples on how you can build visual data sets and models in a much more like educational curriculum type way. Kind of the order of operations that we're going to be going through here is going to be a combination of concepts and demos. This is not like a theory heavy presentation. The idea is that, maybe you've been exposed to 51 open source and the corresponding concepts around 51 and computer vision and visual data set management. Really here, the goal is to kind of show you how you can take things to the next level and how you can start to operate at scale and on a team-wide basis. Like if you understand some computer vision workflows already, how might you apply that to your team and actually start collaborating on these workflows, as well as start automating your workflows, model building, model evaluation, data analysis in a level that you would expect at an enterprise. So if you're in the right place, you're definitely in the right place if you've already taken the Getting Started with 51 and Advanced Data Curation workshops. This is not meant to be inaccessible for you if you have not taken those, but it's certainly helpful if you've been through those before. You would have gotten an in-depth view and introduction to 51. This workshop is centered on 51's enterprise features and workflows. Now, obviously, the fundamentals from the other workshops and the fundamental concepts behind 51 are still going to apply here. We'll really see that largely what we'll be covering can be thought of as like a superset of that which are those fundamentals. What this workshop is not is in-depth on computer vision theory. It's not an intro to ML concepts. It's not an intro to like Python programming concepts, or even necessarily an introduction to 51 basics. Again, we'll reference those basics as we go through the items in this workshop, but the links and resources that Jimmy shared are really awesome resources that will allow you to kind of dive in depth on your own pace. And we also have a whole host of other events that will address these as well. So this is a slide that might look familiar to you if you've seen the other workshops. Again, 51 Enterprise uses fundamentally it is the 51 platform with a whole bunch of bells and whistles that are added onto it. So if your data prevents your models from getting into production, if the idea that data eats models for lunch is something you intuitively and empathetically understand based off of your own work, if you're struggling to understand what's even in your data, and if you want to learn how to train models by curating better data sets, like, again, all these same concepts apply, this is for you. I want to add that specifically, if you work on a team that wants to standardize and scale machine learning workflows, particularly the core data set management parts of it and how the data applies to model performance, this is for you as well. Again, really the core that we're going to view here in 51 Enterprise is how do those concepts that are fundamental around visual AI development workflows, how do those apply when you're working with multiple people that need to collaborate on data sets? And how do those apply when you're trying to go through kind of the practical nuts and bolts of comparing model performances and working with massive data sets that might live in like a cloud hosted environment and you're trying to figure out, what are the edge cases that you need to identify. Those are going to be largely what we cover here. So here's the agenda. We will linger on this for a moment. And what the agenda is going to go through today is a brief overview of 51. Again, we're not going to go through the whole gamut of what's covered in the Getting Started workshop, but we will kind of do an overview/review of the 51 platform. The second will be starting to talk about dataset management at scale. So one big difference we'll notice with 51 Enterprise is your datasets generally aren't going to live on your local computer. Right? When you're working with 51 as either a single user or you might have a setup where you might be connecting your open source 51 instance to some like external file server if you want to kind of put something together. You might have done that. Here, 51 Enterprise at organizations is really intended to connect to some cloud-hosted file service, whether it's an object store or a data lake, and we'll talk about how 51 connects to those. That's going to be critical for managing giant data sets. And it's also going to be critical for understanding what might need to be added to your data sets from like a massive data lake, for example. Maybe you have a data set of thousands or even up to 1 million samples, but your data lake might contain millions, if not billions, of raw data. How do you augment or update your data sets in an intuitive way from your larger, data and media repository that you might be using in your organization? That's largely what we'll talk about here. We'll also talk about out-of-the-box workflow. So once we understand how we might manage data sets at scale, how do we start to use some workflows like data quality management? How do we run scans and analysis on critical issues that we might find in our data set and start to understand the trend and distribution of our data, whether it's visual aspects like blurriness, or brightness, or high contrast or low contrast data, or data entropy, or multimodal data that might have different aspect ratios. Once we understand that distribution, we can start to see what might be underrepresented or overrepresented in our data sets, and therefore how that might affect model performance. Sometimes those extremes are underrepresented, as we'll see, but sometimes they're overrepresented to the extent that model behavior is suffering because of them. What we'll also talk about in these out-of-the-box workflows are model evaluation. So if you apply a model and you generate a set of predictions, those predictions are generally added as labels to your data set, whether they're object detections or classifiers or segmentation maps. We need to understand how the models actually behave, both from run to run within the same model and also comparing models side by side. There are tools for those already, but what makes our job much faster is if we can run those evaluation tools side by side with our data and do things like click into confusion matrices that allow us to very easily pull up what are the false positives of a particular class on a particular model out of a particular run, and at least get a visual idea on where our data might be causing failure modes in the models. Then we'll kind of move into the collaboration aspect, and this will start to get into the nuts and bolts of how practically do we work together on our data sets. That will include just how do we manage the users that are accessing our data. Now, that might be something you're doing individually. It might be something that other folks on your team are using, but it's essential to understand just from an access standpoint how collaboration can occur just based off table stakes items like permissions and visibility. But on top of that, a critical aspect of this as well is being able to share, export, and version our data. And we'll talk about that as well. If you're making changes to data sets, how can we ensure that there's a snapshot history that we could, say, roll back to if needed? How do we know what the diff is between two snapshots of data? We'll talk about that as well. And then that'll also bleed into our discussion on safety and security. We'll learn a little bit about the architecture of 51 Enterprise, just in the sense of whether you're a user or you're more of a platform engineer maintaining the deployment. What does the experience look like, and what will you expect? A little bit of what is occurring under the hood when you're actually using or maintaining a platform like this. And then finally, we'll talk about next steps. This whole agenda is going to largely be a combination of presenting like I'm doing here, as well as kind of as we go through the different slides, I'm going to be hopping into demos as well. There'll be a couple places within this presentation that I'll show you an environment that you can use to kind of go in and explore around a 51 enterprise deployment. It's not going to be the exact same as what I'm demoing here, but it'll give you a good sense and give you a good sense of what the experience looks like. All right. Let me take a quick pause here. I'm not seeing any open questions yet. Again, if anything comes up as we go, you are more than welcome, and I highly encourage you to put those questions into the Q&A. All right, I'm actually showing this here in a moment, this at the beginning as well, just because if you are seeing kind of the interface that I'll be walking through here in a bit, and you just want to learn more and experience experience it for yourself, this QR code here will take you to the try.51 instance. You can also get to it by typing try.51.io in your browser. It will expect a login through either Google, LinkedIn, or GitHub as like a single sign-on, but I'll show it here in a little bit as well, and it'll give you a chance to kind of see what the environment looks like. It is worth noting that there is going to be some limitations compared to what I'm showing. It's more of a read-only environment, so you won't be able to like run end-to-end model evaluations or update data sets in quite the same way that I'll be showing. But again, it will show you an experience that you'll see how this kind of multi-user experience works compared to open source 51. All right. All right. A little bit about me. I won't spend too much time on this. My name is Nick. My background is actually more in the physical sciences. I'm a chemical engineer by training, software engineer by trade. Turns out I like working with bits in an air-conditioned office a little bit more than chemicals in a factory. I found out pretty quickly. I'm based in the southeastern United States in Nashville, Tennessee. It's not quite as gloomy outside as Jimmy was describing where he's located, but still it's kind of that early spring kind of cool weather outside at the moment. Previously, I was at GitLab at Harness, two other software companies before I joined Voxel 51 in more of a technical marketing engineer role here. So lots of demos, lots of tinkering around with computer vision data sets in my role here. I always like to give a little bit of like extra context just so you know that there's the three-dimensional person behind the face kind of in front of you on Zoom. What I really like to do is when I am not in front of a computer screen messing with bits and bytes, I like to try and do the exact opposite, which is turn off my cell phone or at least go out in nature where there's no cell reception signal at all. Ideally, I also like to take pictures from on top of mountains, which is what I'm doing here. So if anyone's interested on what these really awesome views are, on the left is an alpine lake called Kolchak Lake in the North Cascades in the northwestern US in Washington State. Middle is a view from Mount Rainier, which is just southeast of Seattle, also in Washington State. And on the right is Zion National Park in Utah. It is a really, really awesome hike called Angel's Landing, which gives you a great view of the Zion Valley. Okay, enough of that. We're going to start by doing just a quick review. Again, the goal is to really get into the weeds of some enterprise demos of the enterprise platform as quickly as possible. So real quick about Voxel 51, if this is your first exposure to who we are as a company or product, we are the lead maintainers of the open source 51 toolset as well as the developers of the enterprise platform that we'll be showing here in a bit. The name comes from the idea that a voxel is to a video what a pixel is to an image. It's a space-time element of a video. And what's with the 51? Good question. All right, real quick. We are going to do a very quick review of 51. That's why I have overview/review, just to give you a sense of where our launching off point is when we start going through these more advanced workflows. So the premise here is you can't out-train bad data. We find that the ML cycle in the industry tends to go back and forth between heavy amounts of work and effort going into advancing algorithms versus heavy amounts of work and effort going into maintaining both extremely large and high quality data sets to train models. Historically, we've gone through both cycles, right? 70s and 80s, we're talking about like logical and expert systems. We want to train the best algorithms we can to give them the ability to make every kind of possible decision. We then moved to deep neural networks later. That was more of a black box approach that included reinforcement learning. And all the while, there's in parts of those cycles, we kind of lost sense of where data quality plays into ensuring that the models actually make good decisions. And what we've come to learn is that even training the best coded model, that can be broken by having bad data. And generally, data has a much larger entropy as like a whole data set than a model's code does, right? The idea is how can you fish out in your data what might be causing a model to fail. And we'll kind of see a couple of very practical examples of that in a little bit as to like why it's important to ensure data quality and how we can do that within 51. So this has made the news. There's studies on this. Poor data leads to big problems. It leads to model bias issues. If there's underrepresented demographics in data, it can cause the model to have a poor sense of what a typical person, place, or thing looks like, and therefore it gives biased results. When edge cases or critical scenarios aren't properly represented in the training set, that can cause the model to not know what to do in a critical scenario, and that can cause something like the crash of an autonomous vehicle. But even more so than that, it can just cause a reduction in model performance, right? If this is the classic garbage in, garbage out problem. If the model isn't trained on high quality data that shows things properly classified, that has proper object detections or segmentation maps, is not of the size and diversity needed to train the model to respond to a robust number of scenarios, then it just simply won't perform. Like the critical metrics we expect and measure as part of model performance won't be up to par. Where 51 fits is largely as glue, bringing your data and models together. So if you're first using 51, one of the initial easy things to get started with is simply curating and visualizing and filtering data sets, being able to see all of your samples represented, being able to slice and dice those samples, filter them, sort them. At the same, create views and patches of the samples of a particular class, object, or label combination, organize and sort by metadata, all of that. And then when you bring in models, 51 also supports applying model predictions, evaluating those predictions, training models in the context of 51, and then applying the results of the training. And then as we'll see here, comparing and contrasting model performance as well, and then maintaining a loop between iterating on our data set, improving its quality, and seeing how that affects model performance as a result. And again, 51 kind of sits at the center of this. I won't spend too much time on this slide, but think of 51 as a pane of glass for the management of your visual data around the entire ML development cycle. Also, as a quick review, just note when I use the term 51, that can apply to a few different things. 51 actually consists of a few different components. The 51 library is really the Python SDK. So when you are running pip install 51, import 51 as FO, and you start using the 51 classes and methods, that is like the core Python library. Over here on the right, 51 app is really what we refer to as the user interface. So when you open up a web server, when you launch the 51 web server and you open up a session and you're starting to navigate around the user interface, that's what we refer to as the app. And then 51 Brain is a series of computational operations that 51 develops and includes and allows you to run to perform things like embeddings analysis and computing image similarities, for example, to perform similarity search. Like I said before, it's an algorithmic brain that supports the methods and classes that you're using in the 51 library. we're going to be spending a lot of time in the 51 app here. Where this will apply to the kind of enterprise platform is you'll notice some additional features in the app that are made available by the fact that we're on the enterprise platform. But it's also worth noting that the 51 library is maintains backward compatibility. So pretty much all of the classes and methods you use and workflows you're used to using today in the Python library can also apply to like the Enterprise 51 edition. We just have all those bells and whistles we'll discuss on top of that as well. So when I say the 51 app, that is the graphical user interface. Think of it as like VS Code for your data. That's good. And the idea here is that it provides a much more intuitive interface than scanning around your local file system, trying to individually open samples and examine their metadata. And again, if you've used the 51 app before, this will be familiar. This is what it looks like. We're going to spend a lot of time here in just a little bit. So the main kind of front and center interface is showing a view of your samples in the data set. If you open up a data set, by default, it'll generally show all the samples in the data set, but then you can start creating filters and views, and then more powerfully perform operations on those specific views. What we'll also see in 51 Enterprise is that also gives you the opportunity to export, share, clone new data sets off those views, and start manipulating data sets as needed directly within the interface. Okay, so this is what we're going to see here and really what we're going to go through. One of the core values of 51 Enterprise is going to be the collaboration piece. But on top of that, it's going to be these powerful workflows that you can perform with your colleagues as well. So data set management, well, you can already manage data sets in 51, right? But when scale becomes a factor, that is ultimately where 51 Enterprise and its power comes in. When we start looking at massive data sets, those aren't going to be stored on your local computer. They're likely going to be stored in the cloud somewhere, like I mentioned before. How do we connect 51 to those data sets? Well, we'll discover how in just a little bit. We're also going to talk about dataset versioning, dataset permissions. Again, how do we practically manage access to these datasets, additional collaboration tools, advanced data visualization, and then again, a core part of what we discussed will be those out-of-the-box workflows as well. Now, if you're using open source 51, you may have run already some workflows around like data quality and model evaluation. We'll notice that the app interface that we're going to be using here is has an extremely intuitive side-by-side means to very quickly iterate and check and see the distribution of quality issues as well as model evaluation results. Okay, I'm going to pause here for a moment and share this bright orange slide as I check Q&A. Looks like we're okay right now. Okay, so we're going to start at the data set level and start talking about cloud-backed data sets. Now, remember, as I said before, if you're using 51, the open source library that you pip install and run on your local computer, your data sets are generally going to live on your computer's local file system. If you CD into the 51 directory, you can start navigating through your data sets, opening up files individually. 51 will store metadata and labels in its MongoDB database, but the actual unstructured files themselves will generally live on your local file system. Now, there are hacks you can do around that, right? You can have like a mounted directory that's some central file server that ultimately gets mounted on users' local machines, and that's where open source 51 is pulling data from. But again, it's not an ideal situation, and it doesn't have the scale that like a proper data lake would have. And ultimately today, when you have massive data sets of millions and billions of samples, those files don't live on like a traditional file server anymore. They generally live in either an object store or a data warehouse or both, a data warehouse that is ultimately categorizing data that lives in an object store. So with 51 Enterprise, data is ultimately going to live in either cloud-backed media or a data warehouse. And the way we access that is one of a couple ways. So as we'll see in a moment, if your data lives in an object store, there's a feature called Cloud Media that just baked right into the interface allows you to connect to and import samples from a cloud-backed object store. In the case of a data warehouse, there is a feature that we've just rolled out actually called Data Lens that allows you to query and preview data that might live in Databricks or BigQuery or wherever your data lake might live. And I'll show this here in just a couple moments. Again, the idea here is that you have your massive set of unstructured data that lives somewhere, and you need to be able to connect 51 to it so that you're pulling data into a data set that's maintained by 51. Now, the data itself, ultimately, the source of truth will be in that cloud backing. What 51 will do is in the sample view, when you're loading samples, it will cache those samples locally for performance reasons, while at the same time, again, maintaining that source of truth lives in the cloud. So let's go through a couple of examples here. I think the best way to actually show this in action is to see it in a live environment. So the first thing I'm going to do here is jump into, give me one moment, jump into a data set. Now, a couple things you'll notice. This is a data set called BDD 500. This is actually kind of a subset of that of the overall Berkeley Deep Drive data set. Notice I am logged in as a user to 51. So if you're used to 51 open source, what will look a little different is when you're logged in, or rather when you're on 51 Enterprise, you'll be logged in as an actual user. So I'll show that in a little more detail in a little bit. But assuming you're logged in, I am on this data set here. Now, let's say that I've either created a new data set from scratch, or I am importing samples into an existing data set. We have an operation that's ultimately a plugin called import samples. This is the IO plugin that you can install. More on plugins a little bit later. But ultimately, what this allows you to do is to connect 51 to wherever your data lives and then import the data. So whether it's media or labels only, or both media and labels and its associated metadata, we support a host of data set formats. So that's listed here. 51 has its own schema for how data sets are structured, but we also host those in the list as well. And then remember, this is ultimately a plugin, right? So part of 51 here is its extensibility. So if you have like a custom schema that you're using, you can always incorporate, develop a plugin that will allow you to interact with 51. We're going to talk about operators in just a little bit, and that'll show kind of the flexibility that you have here. But out of the box here, or rather using this plugin, these are the data set types it supports. We might have a 51 data set here. And then we will choose the directory that our data lives in. And what this will do is you'll notice kind of the interface here. This connects to a cloud destination. Now, where is this cloud? Like, how do we know what it's going to connect to? That is defined by cloud credentials that you can add to 51 in order to connect to a cloud resource of your choice. And I'll hop over there in just a second. If I click the little cloud button here on the left, you'll notice supported clouds here like Azure, AWS, or Google Cloud. We actually support connection to any S3 compatible object store. So that includes like MinIO or any of the OpenStack variants or any on-prem object store. As long as it follows the S3 protocol, we support that alongside the major cloud providers here. So a couple ways to think about this. So like this right now is an existing data set. So if I actually go to, I'm going to back out of here for a moment. If I go to a particular sample and I look at the file path here, we see this GS followed by a path. This is a path within the Google Cloud object store in Google Cloud Storage. But let's say that I had a new empty data set. Let me just make a new data set here. I'll call it NL. I actually have an NL test already, so I'll call it NL test 2. Well, if I create the data set, right now there's nothing in it. I'm prompted, hey, you need to add samples to your data set. Well, and again, because we're in kind of an enterprise setup here, we're assuming those samples live somewhere in the cloud. They're not going to live on my local machine. In fact, 51 isn't running on my local machine. It's running in Kubernetes somewhere. So we have this IO operator that allows me to import data, and I'm going to connect to a path. In this case, it's Azure Object Store. And I'm going to keep things simple here. Like I'm going to just select what's in the quick start data set to make things fast. And this is the root directory that contains my samples and associated metadata. And again, it knows what to look for because I'm specifying that I know that this is in 51 dataset format. I can choose to add optional tags to the data set on this import. This can be useful if I want to give a particular indicator on what this import represents. It'll allow me to filter by all of the samples that might be in this import. What I can also do is I can delegate execution. So one really neat thing that we can do is I can choose to simply run this in the foreground. So I can uncheck this, hit execute, and then my screen's going to be taken up by like the operation as this executes. But what I can also do is I can choose to run it in the background. I can delegate it to some kind of external compute that 51 has access to. So these actually represent like compute workloads that are in the same like virtual network that 51 runs in. If I were to do that, so I'll do something else a little bit later that schedules the operation. For now, this is a very quick import. I'm actually just going to click execute, and that will import my samples here that live in that directory. And it might take just a minute or two. I'll hop back over to the slides in a minute. I'll show you a different interface that shows where the scheduled operation will run here, and we'll do an actual different scheduled operation a little bit later when we run a quality scan. But you'll notice each data set in the top left-hand corner has this run tab. That's where asynchronous operations will run on a source of compute that you specify. So we'll let that run here in the background. Really, all this is doing is, again, it's importing the quick start samples from the data set that I selected, and then that'll just populate here. Again, I'm calling the data set NLTest2, but it's going to be the quick start samples here. So we'll return to that here in a moment. Just as a quick reminder, the source of the data lives in your cloud object store. Once the samples are imported into 51, when you as a user are looking at that data, like on your computer with the browser open, those samples will be cached on your local machine. It's an environment variable. The name escapes me that ultimately specifies where the local samples are being cached as you're viewing them within your web browser. All right, we'll let that run a little bit longer. While that's running, I want to make note of kind of the second way that we interact with data wherever it lives, and that's through a feature called Data Lens. So cloud-backed media we can kind of think of as like method number one. It's a little bit more of a traditional, I don't want to say basic, but it's a little bit like further, like it's a little bit lower in the stack from an infrastructure standpoint method of connecting to your data sets. The second method is called Data Lens. And what Data Lens does is Data Lens allows us to connect to a data lake. So, and we determine what that data, and you determine rather what that data lake is and how you connect to it. So here, I'm actually going to zoom in a little bit here. Here, I'm in another data set. I'm in BDD 100K validation. Actually, I'm actually going to do this. I'm going to hop back into a different BDD data set here, one that we can see the numbers advance in a little bit more meaningful way. So I'm going to go back to my BDD subset data set. Let's see. Okay, sorry. Let me go back to demo here. There it is. Okay, so also Berkeley Deep Drive here, just a slightly smaller sample set. Right now, there's 615 samples in that data set. I have a much larger repository of samples than just this that live in my data lake. Let's say my data lake is Databricks. I have a schema set up on how to query those samples in Databricks, and I want to connect 51 to it. That's where this data lens feature comes in. So when I was using Cloud Media, this is taking a little while, that's okay. That's just connecting to a cloud object store. Here, we're actually going to be able to connect to and preview and query samples from our data lake. Because what's likely is our data lake is huge. We're not going to want to just do like a bulk import of everything in our data lake. And also the point of our data lake is our data is queryable based off some kind of schema. So ideally, we have a way to connect to our data lake, search for what we're looking for to augment our data set, maybe preview those samples, and then bring those samples into our data set. And we're going to do so in a couple of different ways here. So the way this is done is through an interface called Data Lens. So this is created as what's called a panel. So like this way here is we're opening what's called Python panels, and we've created one called Data Lens. And what we have defined here is a data source. And we can see that this data source is Databricks here. Now, like, where does this come from? Like, how does this data source appear here? How does 51 know how to connect to it? I see these query parameters here. Like, where does this even come from? Ultimately, this is a type of plugin called an operator. So if you've been through the 51 Getting Started in Advanced Curation workshop previously, you've probably heard about this idea called a plugin. If you've worked with software at all, you probably have an intuitive idea on what a plugin is. It's a piece of software you can develop to expand the capabilities of 51. 51 has an advanced plugin framework you can use in order to develop plugins that like perform some other task that 51 might not have like natively in its code. On top of that, 51 also has an operator framework that allows with integration with the rest of 51's features. So for example, with this data lens feature, this connection to Databricks and these query parameters are ultimately determined by what's called an operator. So if I go, leaving this open for a second, if I go over to settings here and I go to this plugins page, and if I actually just search for the Databricks plugin here, we'll notice that we have this Data Lens Databricks plugin that's actually an operator. And this operator performs actions almost as a service account in 51. Now, we're not going to discuss like the nuts and bolts of exactly how you code up operators, but I do want to just quickly show you. I'm going to quickly switch my screen over to Visual Studio just to kind of show you how. Where's my Visual Studio? There we go. Just to show you the relationship between how the operator works versus what we see in Data Lens. So in this operator here, this is just a Python program where we've imported the 51 operator development modules, and we've also imported the Databricks SDK. And here we have two classes that we define, a Databricks connector class and a Databricks handler class. The Databricks connector class basically specifies how we're connecting to and receiving samples from Databricks. And I don't want us to get like lost in the weeds here, but I do want us to see that we have query parameters defined like time of day, the weather that we're querying for in the samples, the detection label as an optional parameter. And then we pass, then we have this method that ultimately calls this Databricks handler class, which constructs the query right here, and then ultimately renders the preview results in 51. And then there's a transform method later on down that will actually transform the samples into 51 compatible data so that we can import it. This connector can be found on the operator documentation on docs.51. This is actually one of the examples that we have there that shows the Python code for how this is developed and how 51 interacts with Databricks and then allows you to pull in samples. Again, this is not something that's like, you know, this first class native out of the box. You install 51 Enterprise fresh, you can immediately connect to Databricks. This is meant to be customized for your data lake and your schema that you're wanting to allow 51 to interact with. So going back here to our data set here. Here's Databricks. And then I might say that, let's say I know that there are some there might be a couple things. There might be some underrepresented samples in my data set. Or I know that maybe my model has trouble with a certain class of samples. And I happen to know that those samples happen to be when it is rainy, city streets, at night, and maybe there are pedestrians. Well, I can select the number of preview samples. So this is just the number of samples that FiftyOne is going to pull from, in this case, Databricks that meets this parameter or meets these query parameters. And in a minute, we'll see this populate with samples that just by visual inspection should match at minimum what we were querying here. We should be able to just see that here in a moment. While this is going, I'm quickly, and there we go. All right. So we can see that after about 20 seconds or so, here we have some rainy city nights. We have it's kind of hard to see here, but there should be some pedestrian object detections here as well in the scenes. And then if we're happy with what we're seeing here, we can always run a different query. We can always run another one, or we can click import data. And we have a couple options here. So what this is going to do is we can say, hey, I want to specify a number of samples that I'm going to pull in from my data lake that match our query. So this is matching the query we set here. 25, 500, 1,000. Or we can say all samples matching the query parameters. Now, obviously, be careful about that because we don't necessarily know yet exactly how many that will be until we run it. For here, again, I'm going to keep things super simple. I might say, I'm just going to say 15. I know there's at least 25. I think there's 25. There might not actually be a full 25 rendered here. But I know there's at least 15. I want to pull those into my data set. Now, right now, I have 615 samples in the data set where I know we're working with small numbers here. I can choose to skip existing samples. So if this sample already exists in my data set, we're not going to like import a duplicate. I can choose to pull it into my current data set, or I can choose to create a new data set and pull it into that. And what I could also do is apply a tag to the sample. So I might say, keeping things basic, maybe import 32725. Or I might say, import rainy data, or just have something that allows me to filter using the views on the left what this particular import batch is. When I import the data, what I can do here is, again, I can run it in the foreground again, or what I can do is I can schedule it to run as a delegated job. So that's what I'm actually going to do this time. I'm going to delegate the operation. And what this will do is, notice this will schedule the import. And then if I go to this runs parameter here, we now see it's scheduled, and it looks like it's fourth in the queue. So it might take a second for that to import. Just to kind of show some completeness here, if I were to do it again, just real quick, I might import something slightly different, maybe some clear parking lot scenes with cars, just to kind of show you here. What we'll see once we import it is it augments our data set with the new data. So once the other import completes, we should go from 615 to 630, just to kind of show the completeness here. Whoops, forgot to do that. We'll see that in action here in just a moment. All right, so then I might do the same thing. I might import data. This time I'll just run it in the foreground. Again, I'm going to keep things simple. I'll say 10 samples, import daytime, augment. And again, these are just 10 samples, so it should be pretty quick. It'll run in the foreground. And we can see they were added. If I go back here and refresh my page, right, we see I now have 625 samples with my new ones just added. And I think my other one is still queued up, and that's okay. Our compute cluster might be a little bit busy right now. Ultimately, though, if we look at this job and I click into it, we can see details like the job. If there's any logs, success or failure logs, that'll run here. And we can see a list of recent runs as well. So we might go back to this and make sure it completed a little bit later. So again, just hitting the point home, the idea here is that we're connecting to your broader data lake or object store to import and manage data. All right. I don't know why this is still stuck executing. That's okay. All right, so this is just the big summary. I talked about this already, so I won't spend too much time on this slide. Data Lens is specifically for your data lake, but it's very extensible. So again, you decide based off the operator how it connects to your data lake, what query parameters are supported. One more quick example around Data Lens actually that I meant to show is I'm going to go to a slightly different environment right here. I'm not going to do the full import this time, but I'm going to go to BDD again and show you a slightly different operator that we have set up for also connecting to Databricks. But if I open Data Lens here, notice that one of our data sources we have here on this one is BigQuery. But if I go to Databricks, notice our query parameters are a little bit different. Again, this is based off the operator we described. Instead of using a set of fixed queries, this is Databricks' vector search capabilities. So what we're going to do is we're going to use contextual text search to look for samples that match that search query. So here I might say pedestrians walking at night. And that'll query the data lake. And then the overall order of operations here will be the same. We've just, in this example, the operator as we've written it is using a different set of query parameters, in this case, vector search. So we'll give it just a moment here. And there we go. And this looks pretty matched up, right? Based off what my search query was. Cool. All right. I'll pause here. Any questions around cloud-backed media or data lens before we go into the really cool stuff around out-of-the-box data quality and model eval workflows? All right. Okay. So I want to provide some context here. And you may have seen this before, but I really want to provide context as to why data quality and side-by-side model evaluation metrics with your data set is so critical, is because it's often really difficult to tell what and why model failure modes are. So number one is imagine a situation. Now, this is actually based off real situations. Imagine a situation where a model is constantly detecting potholes in the road in weird cases where there aren't actually potholes. So that might cause the self-driving car to behave in unexpected ways. It might swerve, it might suddenly brake or slow down to try and get over the obstacle. But when you actually look at the road, those potholes aren't there. Well, that's because there were some visibility and contrast situations in which shadows from trees or down power lines caused by a storm caused the model to misinterpret these, or caused the car to misinterpret these as potholes. So the model was not understanding that shadows cast on the road aren't potholes. It's perfectly safe to drive over. Maybe not in this picture, but if it's just a shadow, it is. But if you have a massive data set, how do you actually pull these situations out that you can use to then evaluate your edge cases and figure out where your data set needs to be updated or iterated, or how your model needs better data to be trained on? how can you actually pull these types of scenes out? Here's another example. You have a security system that uses AI to try to detect security events in a retail establishment. There's a whole bunch of false positive recently on this security system detecting what it thinks is shoplifting and theft. It turns out it was just cold out, and there's a bunch of people in big coats that are just keeping them warm, but not actually being filled up with, the goods from the store that they're trying to carry out with them. Again, this might be an example of a missed edge case that, for whatever reason, the model wasn't able to correctly classify as normal consumer behavior. So one way we can address this is through a data quality workflow. We can scan for and analyze several different types of data quality issues and then see how they're distributed amongst our data. Issues like brightness and contrast, brightness levels, blurriness and sharpness of the data and their relevant extremes. Aspect ratio. Is there a mix of aspect ratios that might represent like improper padding that can confuse a model? Entropy and noisiness, or near duplicates or repeat or exact repeats of samples. We need to understand it for kind of both extremes of reasons. Number one is if you're talking about the extremes of a distribution, we'll need those edge cases in a model to some extent, or for a model to be trained on for some extent, so that it can understand and react to those edge cases. If they're not in the data set at all, then if the model encounters them, we don't know how it might behave. The second reason is if the distribution is too, let's say, unnormalized, or it has too much of an extreme of edge cases, that can also cause the model to behave unpredictably and maybe behave erratically even in normal conditions, because edge cases in critical scenarios are overrepresented in the data. Okay, so we're going to do this data quality workflow first. If I go into, let me think for a moment, what's the best data set to do? Let me go into BDD again. So I'm going to go back into this demo environment here. I'm going to go into the Berkeley Deep Drive data set. And this is also a workflow that gets pulled up as a panel within the FiftyOne app. And we can see that we have these categories of data issues that we can perform analysis on. Now, some of these we've already run scans on. So brightness, blurriness, entropy, for example. We've already analyzed the data set for problems. And what we're actually seeing here is because we've recently added new samples through Data Lens a moment ago, there are new samples in the data set that we might need to rescan to update and include in our distribution. Real quick, I'm not going to run a scan right now. They can take a little while depending on the data set, but just so you know, the workflow is pretty much the same for all of these. If I were to say run aspect ratio, let me get over here. We're going to scan the data set for aspect ratio distribution, and it's the same operational model here. You can either run it in the foreground or delegate it as a background operation. The result will end up being a histogram, generally, depending on the scan type of that metric and its distribution over the data set. So for example, let me go to brightness here. If I click into here, this is the distribution of brightness level across the data, right? So we see a histogram here, and then what we can do is we can set a threshold by which we want to filter the data set. So I'm actually going to put this side by side with our data. Now I have everything selected right now, so this is like the whole data set. Again, it's not a big data set, 615 samples. This is sort of a lab model right here. But what if I want to detect the extreme of very, very dark samples? Maybe our model struggles to perform at night, for example. Maybe there's annotation issues that we can also start to hunt for. Like our model struggles to perform at night, then we might want to check and see whether there's annotation problems with very, very dark samples. Well, we can set a threshold here, and at minimum, we can visually inspect the samples on this threshold. What we can also do is we can tag potentially for further review. We might say that maybe these are too dark, so these need to be removed from the data set entirely. We can add that as a tag, maybe. We can say needs review. So maybe we can have QA folks go in, filter by needs review, and then that'll bring up those samples. What I can also do is I can save this current threshold. By saving the threshold, this preserves this default selection when I open up this issue, such that later if I add new samples, it'll update the distribution according to that threshold. And also this will come up naturally when I pull up this view. I can also reset the threshold as well, and that'll go back to our original view. And then also, again, this is partly just a label for your team. You can also select whether this issue is undergoing review or has been reviewed, and therefore can be considered complete. Going back real quick, I remember I tagged those samples earlier. Under, I believe it's label tags here. Oops. Well, that's not right. This might be, let me go back. There we go. Oh, I don't think that other tag I clicked save on it. Oops. But I do have the too dark label here. And again, that pulls up those samples that I selected earlier. Right. So that's one route to go, right? So data quality panel computes distribution for these major issues. Again, you can choose to scan in the foreground or more likely delegate it as an operation that can run as a scheduled job. As you add new data, you might remember there was a button there that allows you to rerun a scan for additional samples. Think here. Oh, right now looks like zero new samples detected. Okay. But if we did another import, we could rescan it. So that's data quality. Again, the idea here is understanding the distribution of quality in your samples, both for just reportables and also being able to make improvements on your data set. The second out-of-the-box workflow I want to discuss here is the model eval workflow. So this allows you to run and evaluate models directly within the app interface. So if you used open source 51 before, you might be familiar with the model evaluation capabilities within the SDK. What this does is this also brings it into the app, and then importantly allows us to compare critical metrics side by side directly within the app alongside our data, as this screenshot shows here. So it allows us to compare metrics across different models, model runs, core metrics like precision, recall, intersection over union, F1 score. You can actually develop custom metrics to be included here. And what you can also do is you can, these are clickable interfaces where, for example, when we go into confusion matrices, you can click on your false positives and then see them rendered within the app pretty easily. So what I'm going to do now is I'm going to go into a different data set, this manufacturing data set called MV Tech. And what this allows us to do is I already have several sets of model predictions here from a couple different models. One is the patch detection model, which is PAYDEM here. Another one is patch core, which is here. These were run through the evaluate model operation. That can be run within the interface. So if I provide an evaluation key, I can select the predictions field that would be updated, the ground truth field to compare against, the evaluation method, and then like before, I can delegate execution. This is just a visual interface. That's the same as the evaluate model method you can run from the 51 library. But let's say I ran this. and I applied model predictions, or even like, let's say I didn't evaluate the model directly within the app, but I ran it somewhere else, and then I applied predictions as labels and added them to my data set. This next panel here, or workflow called model evaluation, allows us to compare the uh, predictions with the ground truth and the critical metrics that are associated with that. So this manufacturing data set has about a dozen different goods that it has both good versions of and then anomalies of, or rather defective versions of. So for example, like there's good toothbrushes and then toothbrushes with bristles missing that the ground truth describes as a defect or an anomaly. And when we ran these models and applied the predictions, they are class specific in this case, and also uh, detection specific. So we have some for as just classifiers, like is this a cable that's good or defective? We also have some segmentation mask versions of it as well. So let's look, I mentioned toothbrush earlier. Let's go to that. So we have this eval classifier patch core toothbrush model here. I'm going to put it side by side with our data. And what I'm initially going to do is just look at this model as it is, this model evaluation as it is. And then later we'll compare it. So we see that this model ran against all these toothbrush samples. And if we look at some of the critical metrics, this is not a hugely crazy case here. This is just a very balanced model. Precision, recall, F1 score are all equal, which just shows the model's balanced. The class performance is pretty good. So our precision for detecting normal toothbrushes is about perfect. Defective toothbrushes is a little less. We can look at recall. And again, this is just a computation of the the prediction classifications we already applied as labels that 51 is just comparing with the ground truth. We can see F1 score here as well. And this is just a single model and a single model run. And if I look at confusion matrices, we can see that looks like there's one false negative. So it failed to detect one anomaly and then 3 false positives. So there's 3 normal toothbrushes that the model thought are defective. And these are dynamic, or these are clickable rather. So if I click into here, well, actually I'll click, yeah, so here's the false positive for defect. Ground truth says these are normal, but the patch core model says it's an anomaly. And again, we can start to examine our data and see where our model went right and went wrong compared with the ground truth. I can also compare models side by side. So I have the other model that got run called PADEM, patch detection model. And if I compare that model, we can see they're side by side. And I can give myself a little bit of real estate here, and we can compare the metrics together. So it turns out these metrics are the same. The class performance is slightly different. So let's go to precision and recall. Precision and recall are slightly different across classes. And then that'll also show up in the confusion matrices. So we can see that, 4 false negatives compared to 1 here, but 0 false positives compared to 3 on the patch core model. And again, these are clickable and we can compare, oh, sorry, there's 0 there. We can compare them side by side. These are the out-of-the-box metrics that 51 provides. It's worth noting that if you look in the 51 docs under model evaluation, you'll see a section around custom metrics that you can include, where you can code up your own calculation that can be added to the model evaluation metrics if there's any custom metrics that you want to use. All right. Okay. So when we were going through these workflows here, you may have noticed a couple things. You may have seen those kind of benchmarks like, or rather those labels like, sorry, being able to say, where am I? Here. being able to mark things as needs review, in review, reviewed. When you create a view up here, you can actually save something as a new view that gets added to your saved views. Really, the goal here is to allow collaboration with your team on these workflows. So in the final 10 minutes here before the Q&A, I want to talk a little bit about collaboration features. So ultimately, 51 open source can be thought of as single user. When you pip install the program, you're not creating a user account. You're interacting with the library. You're launching sessions that you use within your web browser. Whereas 51 Enterprise has a user database. It actually hooks into your org's auth provider, whether it's Active Directory, LDAP, any SAML compatible user authentication, any OAuth2 compatible user authentication protocol. In fact, what the experience generally is if I go to here, for example, I have this like 51 environment up. If I click login, you'll normally always be redirected to your auth provider first. So for example, this is Keycloak, which is just an open source authentication piece of authentication software. And then I'm logging in with like my 51 SS, internal single sign-on account that then takes me to this instance. So again, your IT team and the platform engineers in your organization will likely be maintaining that or hooking it up to whatever your organization's system is. On top of that, you also have role-based access and permission gating for both data sets and user actions. So you can limit data sets to particular users and groups, and then also users and groups themselves are limited by the role that they have on the platform. So for example, if I hop into here and I go to settings, so I'm actually an admin on this system, so I have access to the settings interface. If I go down to users and groups, here we have a list of users, and each user has a role as to what they can do. Now, right now, we support 4 roles on the platform. Their descriptions are here: admin, member, collaborator, and guest. Descriptions are shown here in the dropdown. The roles are about what you'd expect. And if I go to groups, I can also create groups of users that can be assigned to data sets as well. So I might create a group called QA, and then I can add users to that group like myself, and then maybe Jimmy as well. And then when we're talking about access to individual data sets, if I go back to that BDD data set I was in earlier, there's a manage section that allows me to manage access to the data set. So right now, the default is no one can access it unless they're invited, except me, because I actually created this data set. But I can add a group, say my QA group that I created, and then I can also grant them what actions they can do within the data set. Oops, sorry, right here. So can they just see the data set? Can they tag samples? Can they edit the data set, like modify the samples within it? Or do they have like full managerial access to the data set? This is just important often from like a security auditing standpoint. Hey, do we have gating and access control, preferably an a role-based access control solution, which in fact this has. If I actually go down to roles here, this is a full description of what each of the roles are and then what their permissions are for each role. On top of that, another critical aspect is being able to manage changes to data sets. So we were doing a fair bit earlier of like importing samples to data sets, and we saw how the state of the data set changed because we added samples to it. So now there's 625 samples instead of 610, for example. Data set versioning allows you, in general, allows you to manage data sets through cloning, exporting, creating, and sharing snapshots, and then comparing diffs between snapshots. So in general, if I'm in a data set, like I'll go back to my BDD data set from a moment ago, you'll see these buttons at the top like clone, export, share. So for example, I can clone this into an entirely new data set. In fact, actually, I can clone a particular view. So if I actually go back here, by default, I have this, particular view of all samples. But if I like clicked into this data quality view and I set a threshold, I could actually create an entirely new data set off of this view and only clone this view into an entirely new data set. I can also export an entire data set or view as well. In fact, whether it's the media and labels, just the media, file paths and tags, there's also an example of how to do it with code as well if you're using the SDK. And then finally, I can share the data set where I'm just given a permalink here, either a specific data set or either the entire data set or the view that I'm on in this data set. And I can copy this link and share it with a teammate so that they can open up either, in this case, the specific view or the entire data set. Now, when it comes to versioning, there's a history tab on each data set. So we can see right here that I have a previous snapshot of this data set that I took previously. I'm actually going to go back to the full view here. That was my 615 sample snapshot. I think that's what it is. Let's say I want to take another snapshot of the current view. I just imported new data. So I'm going to take a historic snapshot of this data set. I'll call it after Databricks import. And this creates just a point-in-time snapshot of the data set, and this is browsable. So I can browse previous snapshots. I can also copy a link to each snapshot, and in a moment we see we can roll back as well. So for example, this is the furthest back snapshot, which we see has 615 samples. I can see a reference to it here at the top. I can hop back up to the more recent snapshot, but it's still not the latest version. Or I can go back to the latest version. Actually, it is actually the same as that recent snapshot because nothing else has changed. Let's say, though, that something does change. I'm just going to wholesale delete a few samples. I'll just delete 8 of them. And they're gone. Notice if I refresh the page here, the current state is there are now 8 fewer samples. That's okay, because if I go back here and I choose which snapshot I want to go into, I can roll back to either of these snapshots. Now, quick note, if I roll back to a snapshot that is further back than like the most recent one, this becomes the new head. So this most recent snapshot won't exist anymore. So just be aware of that. So for example, if I roll back to this snapshot, sorry, this top one, this bottom one will still exist afterward. If I roll back to this bottom one, that will become the new head, and then this top one will no longer exist. So for example, let's say I just want to roll back to this after Databricks import one. I can browse into it. We'll let it render here in a moment. Sometimes it takes a second as these snapshots load. Cue the Jeopardy music. We'll give it a moment. Sometimes I just need to refresh it. We'll give this a second. This happens. Sometimes it's just loading in the previous snapshot. Actually, last thing to note, actually, one thing I do want to show as well is as we roll it back in a second, you'll also see in the snapshot history. Let's see if I can open this as a new tab. No, I don't want to switch what I have going on here. We'll let this load here in a second, but we'll click the rollback button here in just a moment. But if you actually look at old snapshots, I think it shows in the GIF here as it goes through. At the top of the most recent version under your history tab, it'll tell you what the diff is between your live state and then the previous captured snapshot. Like what is the sample diff, just so you know whether you have what's basically unsaved work from a snapshot perspective. There we go. Okay, it just took a second. So this is the older snapshot. If I click back to the latest version, oops, that's not what I wanted. Sorry. If I click roll back to this snapshot, it'll basically give you an "Are you sure?" and then I can roll back. And there we are. We are back to where we were before. 625 samples. And then if I go back to my history, we can see that there's no new changes between the previous snapshot because I rolled back to it. Right. Last but not least, I want to just have this as a reference. This is just what 51 enterprise architecture looks like. It's a collection of microservices generally running in either Kubernetes or Docker Compose. Just note that it is more than just the 51 Python library that you might be used to if you're running open source 51. There's a combination of different API services, connects to a dedicated MongoDB, and it'll connect to your user authentication system as well. So if you're just wanting to know what's under the hood, where is it? Real quick. Actually, sorry, Nick. 51 AI. These are the pods that are running on that, and the collection of this is my 51 enterprise deployment. If you're running in Kubernetes. Yeah, great question. Sorry, Braden. Would it be possible to branch dataset versions or maybe just simply make a new dataset off of a specific version? Okay, so the answer is yes to the second part of the question. So if I go back here and I have a particular version, like I browse into it, which again, for whatever reason, it took a minute to pixelate. Hold on just a second. Let me let this pixelate here for a moment. I'll get back to your question here in just a second. Just so I can show it. All right, because it is a good question. There isn't like a native Git style branching involved or historic branching in that sense. But I'll double check if you can just create a wholesale new data set based off that snapshot. If you can't, we'll see pretty quickly. All right. That said, folks, that takes care of most of what was on our agenda here with about 4 minutes to spare. So we'll give that a second. What I want to do now is, while that's loading, I want to jump into any other Q&A that we might have. There was Braden's question here in the Q&A panel. I want to now open up the floor to any other questions that folks might have, and then I'll talk about next steps for about a minute. So are there any other questions from anyone else?
It doesn't look like there's any additional questions, but we do want to remind folks that there's a couple of links in the chat that are also in the QR codes. If you are interested in booking a demo for your team, the link is there for the book a demo landing page and form. Of course, if you want to get a quick overview of everything that Nick discussed today, I highly recommend going to the enterprise landing page on the Voxel 51 website. The link is there as well. And if you want to double click on how a lot of these features work and how they could possibly be implemented in your environment, the enterprise documentation is a critical place to go. The link is there as well. Also, if you have questions and you want to interact with other people that are using 51, I highly recommend the 51 Discord channel as well as the 51 GitHub repo for additional information. And I'll hand it back over to you, Nick, to wrap up Braden's question.
Yeah. So thanks, Jimmy. So yeah, great. And the answer to your question is it's the second one. So you can clone a arbitrary snapshot to a new data set. There isn't like a within data set branching model for snapshots, but you can take a snapshot and then, create basically an entirely new, independent branch, I guess we can call it, which would really just be a new data set within 51. So yeah, great question. And then yes, as Jimmy mentioned, so again, kind of as you're kind of walking through this content here, highly encourage you to first this try 51 environment, which I said I would go to, and I will now. If you go to try.51.ai, you can click into continue with 51 Teams. We actually rebranded to Enterprise, but that login says Teams. You'll actually be let's see if it'll let me. It might catch on to my single sign-on already, but you'll be prompted to authenticate with either GitHub or LinkedIn or Google. I just bypassed that because I'm already SSO'd into my Gmail stuff internally at my company. But if you see some of the data sets that start with try, these act as guided examples. And that's an opportunity to, for example, try BDD, have a little bit of a guided experience. That will take you through. I think in this example, it might be embeddings. Yeah, you'll explore like embeddings visualizations, and there's kind of a walkthrough here you can go to, and there's the equivalent in a couple other data sets as well.